Alright, so our question says, calculate the empirical formula of a substance analyzed to have 55.06% cobalt and 44.94% sulfur. When we're trying to find the empirical formula, I mentioned in class a rhyme. And the rhyme goes like this. It says percent to grams, grams to moles, divide by small, and multiply till whole. This is just a little mnemonic device that helps you remember the steps when you're trying to solve for the empirical formula. So what are we going to do first? Well, the first thing we're going to do is we're going to change our percentage to grams. And that's the easiest step on here, because you always assume that you have a 100-gram sample. And you can assume any gram value, but it's easier to work with 100 when you're dealing with the percentages, because now if I have a 100-gram sample, then if it's 55.06% cobalt, then it's also 55.06 grams of cobalt. And if I have 44.94% sulfur, I have 44.94 grams of sulfur. So that's the easiest step in our little rhyme over here. Okay, what's the next step? The next step says grams to moles. Well, that sounds like a conversion that we need to do. So grams to moles means we want to know how many moles of cobalt are in our 55.06 grams of cobalt. So I'm going to set up my bracket conversion. Whoa, maybe not like that. Let's get rid of that line and make one that's a little straighter, at least hopefully straighter. It's a little better. Grams of cobalt on the bottom, because I want to cancel that. Moles of cobalt on the top, because I want to find moles. And I know from my periodic table that 1 mole of cobalt has a mass of 58.93 grams. And all I did was look on the periodic table to get the 58.93 grams. That's the molar mass of cobalt. So in 1 mole of cobalt, I have a mass of 58.93 grams. Grams are going to cancel. Now I have 55.06 divided by 58.93, and I get 0.9343 moles. 0.9343 moles of cobalt. Now what? Well, I got to find moles of sulfur. So how many moles of sulfur do I have in 44.94 grams of sulfur? Now let's attempt to make our line again. It's good enough. Grams of sulfur on the bottom, moles of sulfur on the top. I know that in 1 mole, oops, having some technical issues here. In 1 mole of sulfur, I look on the periodic table and I see that 1 mole of sulfur has a mass of 32.07 grams. That's right off the periodic table. That's the molar mass of sulfur. So in 1 mole of sulfur, I have 32.07 grams. Grams cancel. Now I do what? 44.94 divided by 32.07. and I end up with 1.4 0.01 moles of sulfur. All right. So let's see. We've done percent to grams. We've done grams to moles. Now I have divide by small. So we go over here to our mole values, and we decide on which one is the smaller. Now the reason we're doing this is because these are the subscripts for the formula, but I can't write CO 0.9343 and S 1.401. We don't write formulas with decimal numbers, so we need to figure out what the whole number ratio is. And the easiest way to do that, oops, sorry about that. The easiest way to do that is first divide by the smaller of the two mole values. Well, the cobalt is smaller, so I'm going to divide both of these by 0.9343. And the reason I can do that is as long as I do the same to both numbers, my ratio stays constant. I'm not changing the ratio, just changing the way it looks. So obviously that's going to be a 1, and this is going to end up being, what does it end up being? 1.500. Now again, when we're doing a problem like this and we get 1.500, just double checking that. Well, it's 1.4995, but that's close enough to 1.5 that we can just call it 1.5. Now I've divided by small. I cannot write CO1 S 1.5 because again, that's not a whole number. So I need to figure out another way to convert it to a whole number, and that's what the last line is here, multiply to the whole. I need to decide on an integer, a whole number, that when I multiply it by 1.5, it gives me a whole number. But whatever I do to this number, I have to do to the 1. Well, obviously 1 isn't going to help because that's going to give us the same numbers. So what if we tried 2? Well, if I multiply this by 2, that gives me 3. That's definitely a whole number. That'll work. But again, if I multiply this by 2, I got to multiply this guy by 2. So that means 1 times 2 is 2. And these numbers here, these are the subscripts. So it's CO 2 S 3. And there is my empirical formula, CO2 S